Welcome to tonight's video on class 44 and 45. We're actually going to talk about the 10 basic functions. We're going to skip the trig functions. The first one is the identity function. That is where f of x is equal to x. The domain and range, remember, for a function like this are all real numbers. And to graph it, 0, 0 would be a point. 1, 1 would be a point. Negative 1, 1 would be a point. And I could just draw the diagonal line. So that is the identity function. The next function is the squaring function, and that's where f of x is equal to x squared. The domain is all real numbers. The range is is greater than or equal to 0. Because if you notice, when you square like 0, 0, 1, 1, and 2, when you square it, is 4. And on the other side, negative 1, 1, and negative 2, 4. We'll put that point back there. And there's our parabola shape for the squaring function. Notice it's symmetric to the y-axis because the y-axis is a mirror. Notice you have the same y-coordinate with opposite x's. The next function is the cubing function, which is f of x equals x to the third. In this one, the domain is all real numbers, and the range is all real numbers. So when you put 0 in, you get 0 out. 1 would be 1. Negative 1 would be negative 1 when you cube it. 2 cubed is 8. And negative 2 cubed is negative 8. So when you graph it, it looks kind of like a snake. And that is the cubing function. Notice it is symmetric to the origin because you have the opposite coordinates. You have negative 2, negative 8, and 2, 8. The absolute value function, f of x equals the absolute value of x. The domain is all real numbers. The range has to be greater than or equal to 0 because it's going to be positive. When you put 0 in, the absolute value is 0. 1 in, the absolute value is 1. 2 in, the absolute value is 2. But then when you put negative 1 in, you still get positive 1. And negative 2, you still get positive 2. So it is shaped like a V. So some characteristics of this, it has a V shape. And notice it is symmetric to the y-axis. The square root function, f of x equals the square root of x. So in this one, the square root of 0 is 0. The square root of 1 is 1. Then the next number you can put in for x is 4 and get a whole number, which is 2. And then 9 would actually give you 3. You cannot put in a negative number, so the domain is greater than or equal to 0. The range is also greater than or equal to 0. And notice the graph looks like that. The next function is the exponential function, where it's f of x equals some number to the x. We'll use e to the x. Notice the variable is in the exponent for the exponential. The general form would be just a to the x, where a is greater than 0, but a does not equal 1. So if you're talking about the domain of the exponential function, you're going to say it's from 0 to 1, and then 1 to infinity. All right, you cannot have a negative number in the exponential function for the domain. Or sorry, apologize. For the domain, you can actually put in any number for x. Sorry. For the range, it's going to be greater than 0 with a parenthesis. Sorry, I made a couple mistakes. Now, when you put this in, let's do E. Remember, E is approximately 2.718, and e to the x is the natural exponential function. E is a irrational number like pi. So when we do this, we're going to have a horizontal asymptote at y equals 0. When you put e to the 0, it's equal to 1. So 0, 1 is a point. E to the first would just be e, which is approximately 2.718. If you put e to the negative 1, that's like 1 over e. So it's 1 over 2.718. So it's almost like 1/2. So notice this graph is going to look like this. It's going to get a J shape. It's a J curve. But you can put in any number for x, and you get out only numbers that are positive for y. Natural logarithm function, or any logarithmic function, we'll do natural, is f of x equals the ln of x. It's the opposite or inverse of the exponential. So because it's the inverse, remember domain and range are just going to flip. So the domain is going to be greater than 0, and the range is going to be all real numbers. And since you had a horizontal asymptote in the last one, this one's going to have a vertical asymptote at x equals 0. And notice the points will flip too. Instead of 0, 1, you're going to have 1, 0. And instead of 1e, you're going to have e, which is 2.1. And instead of negative 1 and 1/2, you're going to have 1 over e and negative 1. Like that. So it's going to look like that. The reciprocal function, f of x equals 1 over x. Basically, you have to understand here that there's going to be a vertical asymptote at x equals 0, because that would make the denominator equal 0. So you're going to have a vertical asymptote there. You're also going to have a horizontal asymptote at y equals 0, because notice the degree of the numerator is smaller than the degree of the denominator. This is kind of like what we just got done doing. If I put 1 in, so 1 over 1 is equal to 1, so the point 1, 1 would exist. And note, remember, it's going to follow the asymptotes. And then if you put negative 1 in for x, 1 over negative 1 will give you negative 1. So the point negative 1, negative 1 exists. Like that. This one also has a reflection property. It's symmetric to the origin as well, because notice the opposite points are on the graph. The logistic function f of x equals 1 over 1 plus e to the negative x. That is used in many applications like biology and business to see the growth of certain things. It has two horizontal asymptotes. So let's scale this. Let's say this is y equals 1. And it also has a horizontal asymptote at y equals 0. The y-intercept, if you put 0 in for x, notice it'd be 1 over 1 plus e to the 0, which is 1, so 1 over 1/2. So it'd equal to 1/2. So that's the y-intercept. So 1/2 would be approximately right. So 1/2 would be right there. And then the graph would go towards the asymptotes this way and that way. So that is the logistic function. The greatest integer function looks like this. This means greatest integer less than or equal to x. So for example, if I said 1.5, greatest integer less than or equal to 1.5, it'd be 1. If I said 0.5, it'd be 0, because that's the greatest integer less than the number. If I said negative 0.3, it would equal negative 1, because that the integer that it has to be is less than what is in the little symbol. So when you graph this, it's going to start at 0, and it's going to go to 1, but then you're going to have a hole. It's going to go up there, and you're going to have a hole, go up there, and it's going to have a hole. It's just going to keep jumping at every integer. Same thing here. You're going to go like that, because basically, and it would go on forever, because basically any number that's like 1.5 for x is going to go back to 1 for y. But then once you get to 2, you can jump up here. 2.5 would go back to 2, and so on. So this is what's called a step function, and it has a jump discontinuity at every integer value of x, because it goes from here down to the next one, and then it would just keep going down forever and ever. And it looks like a step. All right, that concludes the video for tonight. If you have any questions, feel free to ask in class, and have a good evening.